So welcome to all of you in video based IT training. In this video I'm going to demonstrate about B class subnetting. In my previous video I have explained you about the A class subnetting, if you remember that. So please, if you don't go through the previous videos on IP in the playlist IP version 4, please go through all the videos, that it will be easy to understand how we can go for the B class subnetting also. Okay, so in this example I'm going to take B class IP for the subnetting. I'm taking the IP 172.168.0.0. You remember, class is always identified on the base of first octet, and this is the default subnet mask of B class. So in my first example I'm going to take 2 subnet. How we can divide this class full IP into class less IP of 2 subnets. So let's start the process how we can do that. So if you remember, the process is same formula we are going to use 2 raised to power y. What is y? Y, number of bit to be borrowed from host to network side in a subnet mask. So my requirement is 2 subnet here, so means I need to borrow only 1 bit from host to network side. Okay, so default subnet mask, all this is the 1111 here, these first 2 octet. So you have to borrow from the host side, number of bit to be borrowed from host to network side. So naturally I have to borrow these 1 bit. I need to borrow, according to formula, I need to borrow only 1 bit. So what will be this? When I borrow, it will become like this. All this is 111 corresponding to 255. So after this, what will be the new subnet mask? New subnet mask will be 255. When we convert this into the binary to decimal, it will be 128.0. Next is the block size, same process that I have explained in the C class. So what will be the block size? It will be 256 minus the value of interesting octet. What is interesting octet here? Change take place in 3rd octet. Okay, so 256 minus 128. Or second method that I have explained in my last video, last bit has been borrowed, is this one. So from here also you can take the block size, last bit value is 128. Here I am borrowing 1 bit, so first and last is same, but still when we go for more examples I will explain you more that, and my previous video I have explained you that. So in this case the block size will be 128. Okay, so what will be the first block IP range? This one, naturally starting from 172.168.0.0. This is our network ID. Okay, this will be the valid, and this will be the broadcast IP. Very poor routing, again saying sorry. Okay, so hope you understand. Still you understand, writing is poor, but I hope you are able to understand, because total IP can exist in a block is the 128. So 0 to 1. Second thing, this change come into the 3rd octet. So this variation naturally come in this 3rd octet. Variation comes in 3rd octet only, because this is the block size of 3rd octet. Okay, So you can see go 2, 3, 4, 5, 6. It keep going. So when it come 255, it become 1, 2, 3, and 1 point come when it reach up to the 127. Okay. So this is the first block. We require the 27. What will be the second? Second will be this one. Okay. So naturally, block size is 128 again repeating. So here 0 and variation of 128. So it will be the network ID. This is the valid IP range, and it will be the broadcast IP. You can see here the variation of 128 coming into the third octet only. So you have to keep it in mind which one is the interesting octet. That will define our block size 256 minus the value of interesting octet. Now in this B class, variation take place in third octet, so this block size has to be considered in third octet only. This one, and here also you can see this variation comes in third octet. Okay, so this is the way of doing the B class. Only you have to take extreme care in which particular octet variation take place and which one is our interesting octet. So block size will vary only in that particular octet. Hope you clear? So next I want to take one more example here. Now I'm going to define how we can design 4 subnets for B class. I'm taking the same example 172.168.0.0, 255.255.0.0. So let's start the process again. Same thing. The required subnet is 4. I have to divide, I have to break this particular IP series into 4 subnets. Same formula 2 raised to power y that I have to use. So according to this formula, what value I should place here that will fulfill the requirement of 4 subnet. So naturally it is the 2. 2 raised to power 2 is the 4. Okay, so it's our default subnet mask. So I need to borrow according to my requirement. I need to borrow 2 bit here. So the new subnet mask will be this one. I have borrowed 2 bit here and remain all are the host bit. So when we convert this into the decimal number system, the new subnet mask will be this one, 255.255.192.0. This will be our new subnet mask when I'm going to break this IP series, this network ID into the 4 subnet. Okay, same thing next. 256 minus the value of interesting octet will be the block size. So which one is the interesting octet here? I think this one, because the variation take place. This is a 255.255.255. Variation take place in third octet. So this is our interesting octet. What will be the block size? 256 minus 192. So it will become 64. And second method, if you remember, what is the value of the last bit that I have borrowed is the 64. So you can find out the block size by 2 ways. Either 256 minus the value of interesting octet or the value of last bit that I have borrowed. So in this case last bit borrowed is this one. So value here is 64. Okay. So simple, 64. So what will be the 4 different blocks? Same thing. starting here, this is our network ID, this is a valid IP range, but again check block size is in the third octet, so a variation will come in the third octet only. You can see it. You have to take extreme care when you are designing the blocks. This variation come in the third octet. Okay, what will be the next? You can see here this variation comes here in the block size is 64, so next network ID will be 64, first valid IP, last valid IP and broadcast IP. So again the variation come in the third octet. In the same way we keep proceeding. Here 64 plus 64, 128. Network, valid IP range, broadcast. This one is the fourth octet. 128 plus 64 is the 192. So it keeps going up to the 255. It will be the last valid IP and it is the broadcast IP and will be the network ID for this particular block. Now each block have its own network ID, each block have its own broadcast IP. Okay. Only you have to take the care in which particular octet this variation is taking place. You have to take the variation, do the variation in that particular octet, like this and this one. 0 plus 64, 64 plus 64, 128 plus 64, 192. So this variation comes under this. So naturally you can see here when this come 127.255 is 255 saturated, it become 128.0 for the next network ID, because in this case all the host bit get saturated, so it start a new network ID. Hope it is also clear to you. Again repeating, if you have any doubt you can write me in the comment. I will try to reply that as soon as possible. So for more clarification the concept to you, I am going to take a large 250 512 subnet for this. How we can create 512 subnet in this. It will really clear a more picture. So let's start that process also. I am not going to create all the 512 blocks, but still try to clear you as much as possible. Process is again same. So I require 512 subnet here. According to the formula, I need to borrow 9 bit. So this is a default. 9 bit means 8 bit in the third octet and 1 bit in the fourth octet. Then it become the this one. I am going to borrow 9 bit from host to network side. So it will be like this. I have borrowed 8 bit and 1 bit. So total is the 9 bit I have borrowed from host to network side. So what is the new subnet mask? This will be the new subnet mask. 255, 255, 255, because this third octet also get fully occupied by the network bits. So when we convert it into the binary, it become 128 and 1 bit has been borrowed from here, so it become 128. Same thing. Next we have to calculate the block size. In this case you have to take little more care. In this case, because variation is taking place in 2 octet, in third octet as well as in fourth octet. Okay, so you will design 2 subnet here. Third octet block size 256 minus 255, that will be 1, and fourth octet size, the value here is 1. In third octet it is the value 255 and here the value is 128 in the fourth octet. So 256 minus 255, so third octet block size is 1, and 256 minus 128, the block size will be for the fourth octet will be 128, like this. So now first we saturate fourth octet. Fourth octet block size is 128. So starting from 0 to 127. Now you can see here, again I saturate the fourth octet. I give the variation. Fourth octet block size is 128. So it will be the 128 to 255. No more space in the fourth octet. Third octet block size is 1. So I take the variation of 1 in the third. Again reset fourth octet to 0. But fourth octet you have to consider still. It is the 128. So you can see here I have taken the variation of 128 in the fourth octet. Same process keep going on. Here also starting from, I keep the third octet constant to 1 because still our host side have the remaining bits pending for the host. So I give the variation of 128 here because fourth octet size is 128. Sorry, little mistake here. Oh, nothing here. So 129. Go to up to 254 and 255 will be the block size. So in this way, come to the move. I take the, when this fourth octet gets saturated again, so naturally third octet variation is 1 again, like this one. It become 2, again 0, variation of 128 in the fourth octet. Means in this case I have to consider both the block, both the octet, third octet as well as fourth octet. Once fourth octet gets saturated, then we have to give the increment of 1 in third octet. So same thing like here, 127 finish here with the 2 of value of third octet. Then I give the variation of 128 fourth octet. Again some mistake here, it's a 129, sorry by mistake. So it go up to 255. So it keep going, it become 3 0 3 128, then 4 5 6 7. It keep going like this up to what will be the last one point come when we reach the value, like initially it was the 0, then come 1, then come 2. So when fourth octet gets saturated, incremented by 1, fourth octet saturated, incremented by 1. So 1 point come when we reach at this stage, the second last block value. So it become 255 0. So it will be 255 1, go up to 126 127 is the broadcast. So it become 128 is the network ID. I'm doing a lot of mistake. This mistake, sorry. So 129. Oh, whiteboard. Okay. So just I'm going to erase it. Is 0. 0. 0 does not matter. And okay. Okay. So the very last block value will be this. Network ID, valid IP range, and it is the broadcast IP. Now you can see my third as well as fourth octet become fully saturated. So in each value, like in 2, you are getting 2 octet. So in 1 octet, this value can vary from 0 to 255 in third octet. In each there are 2, means 256 multiply by 2 will be equal to 512. Subnet we got here. Got my point? Because this value varies from 0 and last will be 255 in the third octet. So 256, but each value taking the variation of in 2 octets. So total 256 multiplied by 2 is the 512. So So in this way we can do the subnetting of B class. In my next video I will also try to take one example of A class for you. So hope you understand the subnetting of B class. If still you have any doubt, please don't hesitate to write me in the comment. Like, share and subscribe the channel if you really like it. Thank you very much. Hope you enjoyed this.